My name's Jeff Munroe, and I am a professor of geology in the Department of Earth and Climate Sciences at Middlebury College. My fascination is with mountain landscapes and how they evolve over time, and how evidence in mountain landscapes records past environmental changes.
It's finer than it's seen, just pretty colored.
And I've studied and visited and worked in mountain ranges all around the world, but to me there's really no place that's more special and more unique than the Uinta Mountains. I've worked here for nearly 30 years, going back to my PhD research, and I've never stopped.
My name is Gabriella Koltai, and I work as a senior scientist at the Institute of Geology at the University of Innsbruck, Austria.
It's not calcite. Sure, this is something else.
I have a background as a geography teacher, and I did my PhD in geology, and I'm very much interested in caves. I'm curious to know if the little crystals that I see here, if some of this could be calcium carbonate or calcite. So I will use a little very diluted acid, HCl, and then drop it on and see if it bubbles. And if it bubbles from the acid, I know that there is some carbonate inside this sand. You see?
Mm-hmm.
Yeah. And it has quite a heavy reaction. Mm-hmm.
Lots of calcite. The intersection between my work and work of Gabby is our interest in caves. And so we have a grant from the National Cave and Karst Research Institute in New Mexico to study caves in the Uinta Mountains, and that's what we've been doing for the past 2 weeks.
When I look at this, it's just really neat to imagine that there were thousands of years of water running over the slope to deposit the flowstone, and then boom, that turned off, and we started to get individual drips that grew the stalagmites.
Yeah, there's sediment all the way up.
Caves are places where, in some ways, nothing changes. Beneath the ground, everything happens very slowly. Evidence is recorded there for a very long time. But at the same point, things, of course, do change in caves, and they can change quite fast. So some of the caves we've visited in the past few weeks contain ice, and the ice was very different than it was just a year ago. Fast change for geology, but at the same time, features in these caves have been unchanged for hundreds of thousands or maybe millions of years, which is just humbling to see that and think about just how much time that represents.
This is probably centuries, if not thousands of years of accumulation of this fluffy orange mineral.
So in layman's terms, this is not dirt.
It looks like dirt. It is definitely not dirt. This is a unique occurrence. You don't see this in many places. Really only a few in the whole world.
This is minerals precipitating out of the ice when the ice forms.
Yeah, and many cases when the ice is completely gone, we find these minerals in the ice-free passages of caves, and this gives us a clue. This is a first order, I would say, evidence that there was ice in the cave, probably at that place.